Here's the standard RAG pipeline everybody teaches. You take your document, create embeddings, store them in a vector database, and when somebody asks a question, you retrieve the relevant chunk and feed them to an LLM. The pitch is always the same. Just embed your documents and ask questions. It sounds magical. And for simple use cases, it works. But here is where things get interesting. Now, let me show you what actually happens when you throw real documents at a RAG system. Chunk lose context. When you split documents into 500 token pieces, you destroy the relationship between sections. The chunk about the purchase price does not know it's connected to Exhibit B 3 pages later. Cross references become invisible. Embedding can't follow these links. Similarity is not the same as relevance. Just because two pieces of text are semantically similar does not mean they are both useful for answering your question. And there is no reasoning happening. RAG is pattern matching on surface level. It does not understand your document. It's just finding things that look similar. Let's talk about the main culprit. So here's what a RAG system actually sees when you ask a question about a purchase price. So chunk 47 talks about purchase price, and then it cuts off. Chunk 48 mentions section 2.3b, which outlines the methodology. These chunks are neighbors in the document, but the RAG system does not know that. What you actually need is a full context. So it's actually a chain. Documents are structured. They have hierarchy. Chunking destroys all of that structure. Now, here's a typical document send. 10 documents in a folder. When you ask a question, you might need information from 3 or 4 of them, but they reference each other. So look at this line. The term in Exhibit B are subject to Schedule 4.2. This is one sentence that spans 2 documents. So a RAG system retrieves one chunk. It might find the sentence, but it won't follow the chain. Now the problem is this is not a niche problem. Legal documents, technical specification, financial filing, they all work in the same way. Cross references are the norm, not the exception. What if instead of computing chunks and hoping for the best, we actually let the AI navigate documents like a human would? Think about how you read documents. So let me give you a concrete example. You are looking for the return policy. So what do you do first? You don't read page 1. You look at the table of contents. Chapter 3 is return policies. That looks relevant. So you go to page 28, scan for electronics. Now this is how intelligent document search should work. Not find similar text, but understand and navigate. So here is what a RAG system would have returned for the same question. Some chunks that mention return policy exist and tells you to see section 3.2. It found a related text, but not the answer. But the agentic approach finds the actual answer, follows the references to extend warranty info, and gives you complete context. That's the difference. Okay, now how this agentic file search looks like. This is different than the normal agentic RAG approaches that you probably have seen. So it starts with a user query, same as a RAG. But instead of retrieving pre-computed chunks, the agent scans all the documents in parallel. It gets a quick preview of everything all at once. Then it decides which documents are actually relevant and does a deep dive, reading the full context of all those files. And critically, if it finds a reference to another document, it goes back and reads that too. I call this a 3-phase strategy. Phase 1, get preview of all the documents in parallel. This is fast. You're not reading everything, just enough to categorize. Now phase 2, now you read the full content of the document that look relevant. And phase 3, backtrack. If document A says see document B and you skipped document B earlier, go back and read it. So the agent decides what to read based on the question. That's the key difference from RAG. Okay, so let's summarize the fundamental differences. RAG uses pre-computed embeddings. They are fixed at index time. You get the same chunks no matter how you phrase your question. Agentic file search is dynamic. It adapts to each query. Different question leads to different exploration paths, and it follows logical connections, not just semantic similarity. Now, the practicalities matter. You're going to be using a lot more tokens. Now, I'm not saying RAG is useless. It has its place. So use RAG when you have simple question answer or large corpus, when documents are independent and don't reference each other, and when speed is critical, RAG is faster. Use agentic file search when you need complex multi-document reasoning, when document reference each other, when structure matters like legal or technical documents, and when accuracy is more important than speed. They are different tools for different jobs. So in summary, RAG is retrieval. It finds similar text. Agentic file search is reasoning. It understands documents. Embedding finds similar text. Agents understand documents. And I think future is not just retrieval, it's exploration. Okay, so now let me show you a practical example before technical explanation of how this works. So here's a quick demo of how this agentic file search explorer looks like in practice. I can select a folder. There are 26 different files in it. This is dummy data from a large acquisition that I created. The file varies from a few pages to tens of pages. Now, since this is regarding acquisition, we're going to ask a question like what happens to employees after the acquisition, cover retention, benefits, and non-competes. A traditional RAG system may not be able to answer complex questions like these. This is going to be relatively slower compared to a traditional retrieval step. So you can't really use this for real-time chatting. This is extremely helpful if you want more accurate answers, but you're not constrained by latency. Second, it uses an approach similar to what coding agents like Claude Code does. So when you ask it for a code change, Claude Code is going to use the grep command along with regular expression-based search mechanism to look for code snippets that are most relevant to the user question. It does a very similar thing. It intelligently identifies which document to process. It doesn't read all of the documents all at once. So here's the answer that we got. You're going to see that it cites the files in line where the information is coming from. It talks about the employee retentions, how many total employees were there. And then it talks about benefits and equity for each one of them. It also talks about non-compete. And then at the end, it lists all the sources that were consulted. Now let's walk through the step-by-step process of how the agent was thinking about it. So first, it used the scan folder tool. We're going to go into the technical details in the later part of the video. So this uses a parallel scan to categorize all documents in the folder based on their relevance to the employee matters. Then based on that initial assessment, it decided to parse this one document which it thinks is most relevant. It also explicitly cross-references several other documents, key employee retention agreement. These are different documents in the folder. And you can see the agent is reading through the document and trying to identify if it's cross-referencing any other document in this folder. Now, this is the key innovation because in a lot of technical documentation, whether it's legal or financial document, you're going to see there are cross-references to different documents. So the agent is smart enough to identify those cross-references and then go and look for those specific documents. So after reading through the first file, it goes and reads through another file, which is cross-referenced. It does the same for a few other files as well. In here, it says, I have identified the key employees and their retention bonuses, but I need to find the specific terms for the treatment of equity awards. So it's backtracking here. And then it identifies that there is another file that I should be looking at. So it looks at a couple of other files, reads the content of those files, and based on the information that it has collected, it comes up with the final comprehensive solution. Now, if you were to use this same prompt in a traditional embedding-based semantic similarity retrieval system, or even just keyword-based retrieval system, it will not be able to go through this multi-step process, even if you're building an agentic RAG system based on semantic similarity. But here, you get a lot more comprehensive responses. Now, a couple of very important points before I show you the technical details. The agentic file search is going to be a lot slower compared to traditional RAG system. It's going to use a lot more tokens as well. So it's going to be relatively more expensive compared to a traditional RAG system where you reduce the context that is going to be fed into the large language model. Now, the good news is that if you are running a completely local model, you can also use a long context open weight model for this purpose. But the bottom line is that you want to use this system if latency is not an issue, and you can wait for more accurate responses that is going to take more time. Okay, so now let me walk you through how this system was built. I'm not going to walk you through the installation process. Link to the GitHub repo is going to be in the video description. It's pretty straightforward to install this system and run it locally. So this is File Search Explorer, an open source agentic document search system built on top of the llamaIndex example. Let me show you how exactly this is built. So here's the high level architecture. A user query comes in and goes to the workflow engine. The workflow coordinates an agent which talks to Gemini 3 Flash for decision making. Now, in this case, the agent does not just return text, it returns structured action. There are 6 tools that the agent can use. Think of these as the agent's hands. It can scan folders, preview files, parse documents, read text, search for grep, and find files with glob. The agent decides which tool to use based on what it has learned so far, and it's not a fixed pipeline. Also, you don't really see any indexing step here. Now, let's talk about the core components. First, the workflow engine. I'm using llamaIndex workflow for this. It's event driven. The agent emits events, the workflow reacts. This gives you async execution, timeout handling, and clean separation of concerns. The second is the agent. This is a thin wrapper around Gemini 3 Flash. You can replace it with another model if you want. The important part is structured JSON output. The model returns a schema, not free text. The third is the document parser. In this case, I'm using Docklink. It's open source and it's run locally. Now API calls for parsing. It handles PDF, Word documents, PowerPoint, and everything that you can imagine. Everything gets converted to clean markdown text. I personally like a standard format that the agent can work with. So here are the 6 tools, and let me walk you through each one of them because this is the core of the whole pipeline. So the first one is scan documents. This is the most important tool. It scans all documents in folder in parallel and returns quick preview of each one. The second one is preview file. So it's a quick preview of a single document. We take about 3000 characters, roughly the first page, useful for spot checks. The third one is parse file. It's full document extraction. This is the deep dive. You get everything. Then there is a tool for read for plain text files, faster than parse files when you don't need document processing. Then there is grep, which is regular expression search within a file, useful for when you're looking for specific patterns. Then the last one is glob. It finds file by patterns, like find all PDFs in a folder. The agent chooses which tool to use based on the current context. The decision making is where the intelligence lives. Let me zoom in on the scan folder because this is the key component. Now, here is the implementation. It finds all documents in a folder, then uses thread pool executor to process them all in parallel. 4 workers by default. Each document gets a quick preview about the first 1500 characters. Now, why does this matter? There are 3 main reasons. First, a single API call, instead of the agent calling preview file 10 times, it calls scan folder once and sees everything. 2, parallel IO. Document parsing is IO bound, so parallelism gives you a real speed up, about 4 times faster than sequential. And the third reason is informed decisions. The agent can categorize all documents all at once. These 3 are relevant. These 7 I can skip. So this is the intelligent filtering step. Okay, let me show you how these tools get used in practice. The system follows 3-phase strategy. So phase one is parallel scan. When the agent encounters a folder, it uses the scan folder to preview everything at once. It's a quick, broad coverage. Then there is phase two, which is deep dive. Based on those previews, the agent identifies which documents are relevant and calls the parse file on each. Now, it's reading the full content in this phase. Then there is the last phase, which we call backtrack. If a document says, say, see Exhibit B, and the agent skipped Exhibit B in phase one, it goes back and reads it. The system prompt explicitly tells the agent to watch for references and backtrack when needed. Okay, so let's talk about the agent's decision loop. What happens on each iteration? So the agent receives full conversation history, the original question, all the tool calls so far, all results. It sends those to Gemini 3 Flash, which returns structured JSON, not free text, just a schema. And then the JSON contains an action type. Three possibility. One is tool call, which means use this tool with the parameters, go deeper, which means navigate to this directory, and stop, which means I have the answer. So after executing the action, the result gets added to history and we loop. This continues until the agent says a stop or when it hits a timeout. Okay, one optimization that matters is document caching. So when parse files get called, we first check as cache. If the document was already parsed, maybe from a preview or previous question, we return the cached version instantly. Now implementation here is simple. A dictionary mapping file paths to parse content, parse once, reuse everywhere. This matters for backtracking. If the agent previewed a document, then later needs the full content, the preview work isn't wasted. Next, we're going to look at how does the agent know when to backtrack and cross-reference detection. So we tell the agent to watch for patterns like see Exhibit A, as stated in the document, refer to section 4.2, and so on. These are in the system prompt. So when the agent encounters a reference, it checks, was the document in my skip list? If yes, it backtracks and reads it. If the reference document wasn't even in the folder scan, it might use glob to find it. This is where the agentic part shines. The agent is reasoning about what it needs, not just pattern matching like simple rack system. The system is designed to be extendable. You want to add a new tool. There are simple 4 steps. Define the function in the fs.py, add it to the tool directory in the agent.py, update the tool in models.py, document it in the system prompt, and you're done. Now you want to swap the LLM, replace the Google generative AI import with Anthropic or OpenAI, just update the generate call function. The rest of the system does not change at all. The architecture is modular. Our tools, LLMs, and workflows are separate concerns. Okay, some key insights from building this. Parallel scanning is crucial. Scan folder call gives the agent full context to make smart decisions. Without this, you are making dozens of round trips. 2. Structured outputs prevents errors. When the LLM returns a schema instead of a free text, you eliminate an entire class of bugs. You don't have to worry about regular expression, no parsing failures. And 3. Backtracking enables thoroughness. The ability to revisit skipped documents based on cross references is what makes this work on real documents. So the code is open source. Link is in the description. If you want to see more deep dives into agentic systems, let me know in the comments. Thanks for watching. And as always, see you in the next one.